Today we're talking about creating and graphing quadratic equations using vertex form. We've already talked about factored form, we've already talked about standard form, so this is actually the final and last of the three. So quadratic graphing takes on a whole new sense in vertex form. Now, to understand vertex form, we're going to need to go look at completing the square. So follow along with me for just a minute as I take an equation in standard form, a quadratic equation in standard form, and manipulate it using some completing the square methods. So first of all, I need to have just a regular x squared when I complete the square. So I'm going to factor out a 2 using greatest common factor, so that inside the parentheses I just have x squared plus 12x plus 35. Then I'm going to space it out so I can actually add the b over 2 quantity squared, right? Now this is different just a little bit because it's not equal to 0. This is still what's considered completing the square method, but it's going to look just slightly different from what we did in class. First of all, b is of course 12 in this quadratic. So I'm going to take b over 2 all squared and add it to my equation, right? Now, since I'm going to have that same value again, but this time it's on the same side of the equation, I need those two numbers to cancel each other out. Not that that's super important for you right now, but I'm going to take that same value and subtract it as well, so that when I add that number and subtract that number, what I did was added 0 to this side. Now 12 divided by 2 all squared. 12 divided by 2 of course is 6, and when I square that value I get 36. So I have exactly what I had before, but I added 36 and I subtracted 36, so really I didn't change anything about my equation except the look. The reason I did that is because now I'm going to take this portion of my equation, and that's my perfect square. I get x plus 6 quantity squared when I factor x squared plus 12x plus 36. Then I'm going to take the 35 minus 36 portion of my equation, and when I combine those like terms I get a negative 1. Then I'm going to write in the rest of my equation. Now to simplify and change this into what's called vertex form, I'm going to distribute the 2 throughout my parentheses. So I'm going to do 2 times x plus 6 all squared and 2 times negative 1. What that's going to look like is 2 times x plus 6 quantity squared minus 2. I get that by distributing the 2 to both sets. And this is what we call vertex form. Now vertex form is usually the easiest of the 3 different forms for quadratic graphing. So let's take a look at what happens. I'm going to take that equation that I just barely got, and I'm going to show you the general form for vertex form quadratics. Notice I have an a out front. That's just a regular, constant number like the 2. I have x minus a number that we're going to call h, and that's all squared. And then I'm going to add a number that we're going to call k. That's the general form for quadratics. And when I have an equation that's set up in vertex form, my vertex is simply hk. The equation actually gives me the numbers that belong in my vertex instead of me having to go and find them. A couple of things to notice here though. I need you to notice that h is being subtracted from x, and that k is being added onto the end of my form. That's going to matter in just a minute because signs are going to be important here. So we're going to take our example and we're going to rewrite this formula just a little bit so that it looks more like my vertex form with the subtraction and the addition. Notice that is not what I have in my final equation, and that's okay, but I'm going to have to be able to identify h and k. So I'm going to rewrite this just a little, nothing major, but I'm going to change that addition into subtracting a negative. That's exactly the same thing, but now I'm going to have some subtraction where I need it for vertex form. And I'm going to take this negative 2 or subtract 2 on the end, and I'm going to change that into adding a negative 2. I didn't change the number, I just changed it into an addition instead of a subtraction. Now I did that for a really important reason though, so that I could find h and k. When I have subtraction inside my parentheses, I can just take that negative 6 and put it as the x value of my vertex. And if I have a an addition on the outside of my parentheses, I can take that negative 2 now and put it as the y value of my vertex. If you take a look at your original equation, x plus 6, and I got a negative 6 out, it's almost like what's inside the parentheses, you can take the opposite of that number and use it as your x value. And whatever comes after the parentheses, like this minus 2, I can bring that straight down and put it as the y value in my vertex. And once you know the vertex, everything else is going to fall into place. We're going to have our vertex of hk. The axis of symmetry is simply going to be x equals h. Usually we had to find the axis of symmetry first and plug it in to find k. This time the vertex is going to give me my axis of symmetry value. To find the y-intercept, I'm still going to have to plug 0 into my original equation for x and solve. And then the number in front of the whole thing, or a, is still going to tell us whether the graph opens up or down. Of course, if a is greater than 0 or positive, our parabola opens up. And if it's negative, it's going to open down. So let's take a look at what happens in that same example from before. So now I know that a is 2, h is the negative 6, and k is negative 2. Those are my 3 really important values in vertex form. My vertex, of course, is h comma k, which I've got, which means my axis of symmetry is going to be at x equals negative 6. I simply bring my x value down, and I already have my axis of symmetry done. I know that this parabola is going to open up since a is a positive number, and since it opens up, I'm going to have a minimum value, and my minimum value is negative 2, coming straight from the y value of my vertex, or k. And then to find the y-intercept, remember I'm going to take my original equation, I'm going to plug a 0 in for x, and I'm going to simplify. Of course I need to do what's in the parentheses first. 0 plus 6 is 6. Then I need to do exponents, so 6 squared is 36. Multiplication comes next in order of operations. 2 times 36 is 72. And when I subtract 2, I get 70. So then I can take all of that information, the 0 and the 70, and put it together to get my y-intercept. Let's go through this again so that you can have another example in your notes and follow along so that you can understand it a little bit better. I have my original equation, and fortunately this time it's already in vertex form. Most of the problems that you see will already be in vertex form. I need to identify A, H, and K. Remember, A is the number in front of the whole equation, in this case a -1. H is what's being subtracted from x, in other words, 4. And K is the number that's being added on the end, in this case 3. So once I have A, H, and K, everything else will just fall right into line. First of all, my vertex, remember, is HK, so my vertex is 4, 3. Which means my axis of symmetry is going to be x equals 4. I use the x value of my vertex as my axis of symmetry. Since A is negative, I know my parabola is going to open down, which means I'm going to have a maximum value, and thanks to my vertex, I know that my maximum value is going to be 3. To find my y-intercept, I'm going to plug 0 in for x, or substitute 0 in for x. I'm going to do what's in the parentheses first. 0 minus 4 is -4. When I square it, I get a positive 16. 16 times -1 is -16. And when I add the 3 at the end, I get -13. So my y-intercept is at 0, -13. Now let's put this on a graph. I'm going to put my axis of symmetry on first, which is x equals 4. Then I'm going to put my vertex at 4, 3. I'm going to put my y-intercept on next, down at 0, -13. And thanks to my axis of symmetry, I can reflect that across to give me a third point. And after that, that's probably all I need to get a really good indication of where my parabola is going to end up. Make sure to write down any questions you have so that you can bring them to class and remember what to ask. I hope you're having a great day, and I'll see you next time.